Thanks everyone for joining. I think we will get started. I'm pleased to introduce Fiona Lee. Fiona Lee, Manager of Analytics and Data Science Marketing Technologies at Ticketmaster. Ticketmaster, along with its parent company Live Nation, is the world's largest ticket seller and the #1 live events and festival promoter. Fiona is the owner of the customer segmentation and lifetime value projects of Ticketmaster. Her previous experience includes, but not limited to, consulting from PricewaterhouseCoopers, providing data solutions to the largest tech companies of the Bay Area. Fiona received her Master of Science degree from Carnegie Mellon University. As I'm repeating the all sessions, so there will be a 10 minutes Q&A towards the end of the presentation. So I will request everyone to stay back in the presentation, not to move on, so that we can record them clearly, both the questions and answers. So she will be presenting a talk titled Know Your Customer. Please join me in welcoming Fiona.
Thank you, everyone. My name is Fiona Lee, Manager of Analytics at Ticketmaster. Today, I'd like to take you through a journey on how to implement a winning strategy driven by customer lifetime value. So about 20 years ago, our marketing professor mentioned that the essence of marketing is actually its arts. It's not science. It's the art of attracting and keeping your most valuable customers. And as most of the business are transitioning from a product-centric to a customer-centric business, and right now different schools of thoughts coming and people are trying to address the issue how to attract your most valuable customers using different methods. Today, I would like to introduce a method which is used and implemented at my current company, and it's using the customer lifetime value. But for the presentation purposes, I'm still like to take you through a journey and use our business case. What we will be covered today. So first of all, I will give a short background about what is customer lifetime value, why do we care, and next, how CLV is used for a business decision. Then we will take a deep dive on beta geometric and beta-binomial probabilistic models. And finally, I'd like to share some of our suggestions, advice on how to select a CLV model for your business. Now, imagine you're going to open a boutique movie theater right across the street in the University Village. Let's call it popcorn and soda. You have your enough fundings and you have setups. You figured out what is the projection system, how is the sun lighting works. You figure out the snack bars and figure out even like the emergency exits. So what you gonna do next? You probably want to do some marketing research. You probably want to figure out how can I get my first and my new customers. Then you did a little bit of market research and you found out for a similar setting or a similar movie theater, the lifespan of your potential customer is about 5 years. And on average, people visit the similar theaters spend about $20 per month. Then you try to do the math and to answer the question, how much should I spend on acquiring a customer in the first year if I would like to maintain a fixed up 20% of the margin? So basically, you want to keep like 80% in your pocket. Let's do the simple calculation. And by 20 months, $20 per month, 12 months per year, then get 80%, and I will end up with $192. Fair enough, easy. Then the next step, I want to figure out what is my projected CLV. Since I know that on average, a customer will stay with me for 5 years, then I get my CLV as 1,200. That's nice and easy. And imagine that Pop and Corn becomes a huge hit. And you have actually earned enough money to get an MBA at Marshall School of Business. In your first day of Marketing 101 class, and you were giving this slightly complicated equation by the professor, And you look at this and you figure out the only difference between this one and the previous one is because this one takes into consideration of the concept of net present value. So you open your Excel and you try to answer exactly the same two questions. How much should I spend? And very lucky enough, and you got the same number. And then you try to calculate, follow the equation, and calculate your CLV. So you still using $20 times 12, and then you multiply out those ugly little something over there, the r power t, and divided by 1 plus d and a power t. So that gives you a total of $700. Note that this number is slightly smaller than the previous one. And you feel, which formula should I choose? Which one is right? So as a matter of fact, both numbers are right, and both equations are valid. And but what we're going to be doing here, we need a business decision. So here comes the thoughts. Both of the equations are valid, but both of them have flaws. For example, this one, if we look at this equation, the t here is a constant. What is the assumption here is we assume each customer has the same retention rates. So the retention rate is a constant. But this is not the truth. We have the different reasons of not buying stuff from certain stores. We have our certain reasons of not going to a movie theater for certain reasons. The weather is not good, I'm not feeling well, I don't like the movies on, so there are tons of reasons. So there are different reasons I'm not going to a movie theater, period. So that means the retention rate cannot be constant. As a matter of fact, so from the research perspective, as a customer's tenure goes, the retention rate actually goes up. So the longer you stay with the business, and you have a higher retention rate. And there a second flaw of this equation is if we noted that sigma, the big T on the sigma, which is the upper bound of the summation, and we don't know that. We cannot tell until the customer tells us, hey, I'm not going to be purchasing, or I'm not going to be seeing a movie from you anymore. So the big T is also our constant in this situation, but we don't know that. Then what should we do from here? So here comes a suggestion. As of step 1 or step 0, if you're a computer scientist, and there is you need to classify your customer base first. And when I say that, that means you need to decide how do I make money? Through contract, subscriptions, or through a non-contractual basis. From a contract, you basically, the customer death. So from the customer segmentation word, if customer is not purchasing from us, we call them dead. They are like dead, period. Okay, out of the system, out of the equation. So customer death is not observable in this situation. Oh, sorry, it's observable in this situation, and the models are often used is a survival-based approach. It's very similar to what we have done many years for the medical fields. So it's using a survival-based approach. And from a non-contractual business setting, customer death is unobserved and often modeled while probabilistic models. Here are some examples of the companies we're very familiar, and just to give you an example. So Netflix, for example, is a contract base, and we pay the monthly subscription fees. And also there's the idea of discrete versus continuous. So discrete is the idea of your purchase. In this situation, is your monthly payment only occur at a fixed period or frequency. But for continuous, and the purchase can happen at any time. And in the next quadrant, where is the non-contractual and the discrete business model. So our popcorn and soda fell into this example, Ticketmaster, also refill drugs, donation drive. also fell into this quadrant. And on the lower hand, on the lower left side, and we have our contractual and continuous business settings. Basically, purchase can happen at any time, and you still have a contractual relationship with the business. For example, we pay the annual fees to get the Chase Sapphire card, or we have a contract with the utility companies. But the usage of credit cards can occur at any time. And also, we have the non-contractual and continuous situation where we have like doctor's visits, retails, and hotel stays. Just bear with me a second. And there's another type of business models. Those are the emerging, most likely are mobile app companies, like the dating like Tinder, Coffee Meets Bagels. You can do like your monthly, weekly subscription, and then you can also like buy different like our in-app purchases. So those are like also Amazon and Google Play, which they already have the in-app purchase, and they're recently planning to launch the subscription model for their gamers. So I walked us through about the different business, customer business bases. And I want to demonstrate our example about our typical purchasing journey. This is within the idea of discrete and contractual, non-contractual basis. So I still have that icon there. That means we are still in the popcorn and soda story. So thinking you are in a movie theater, we run a report and we see 3 customers, Alice, Brian, and Charlie. So Alice, every week I have these movies on. And it seems like Alice is a very loyal customer to us. She comes to see a movie every week. We basically got her from the movie from the Phantom of Menace, and which, by the way, is my favorite. And she comes here to see every movies. And after 6 weeks, and we don't know yet. So we don't know yet when she will be making the future purchase. But we observed that she constantly and making regular purchases. And on the second customer, Brian, we saw him made a first purchase, and then he made a second purchase. He came to see the movie A Star Is Born, but we don't know whether he will come back when the 7th movie is coming. So basically, we don't know does Brian follow our cycle of purchase, or he just interested in certain movies, like interested in Lady Gaga. We don't know about that. And also, we noticed that there is another person named Charlie, and who become our customer, but he never comes back for the past 5 weeks we have observed. Is he still alive, or he already dead? Like, we don't know. So as an owner of the movie theater, I have 4 movies lined up. I ask my managers, hey, so what do you think those people, will they coming back? So it seems like Alice is a frequent viewer. She probably coming back. And how about Brian? Is he gonna be coming back at Godzilla? Because it seems like he comes back every 3 weeks. That sounds really weird, but I'm curious about it. So we cannot use our judgment, or we cannot tell simply by the patterns of when they are making the purchase from us. One of the customers in this slide, I'm gonna be constantly using this person as an example. So as the previous slides showed, and when we're looking at the customer purchases, we break it out by past purchases and future purchase. And I would like to give the full definition, as a lot of companies already adopted. It is defined as the total profit of the entire relationship with a customer throughout the customer journey for both the past and the future. And if we want to run, we can run the reports to get the past, but it's hard to get the future. And what we're going to be talking about, that's a key point here, is we would like to give you some tools to make predictions about future transactions. And let me break it out. So future transactions encompass of numbers of discounted expected residual transactions. And I don't even want to pronounce it, and we can simply remember this as DIRT. And we use DIRT and times the predicted order value, which is a dollar amount by order. And the predicted order value, which will be predicted using a gamma or span model. If you do a little bit of research, that will give you the answer very straightforward. But what is more interesting is the number of transactions they will be making. This is our focus today. Also, in some of the literatures, they specify using CLV and times of profit margin, and for the profitability derived from CLV. Okay, so popcorn and soda is very, very successful, and it has expanded to 20 more college towns, not only SoCal, but it's become a big or a medium-sized startup. Now we not only have our marketing team, but also have our data science team. And one day, in a memo from the head of the marketing to the data science team said, basically, we have this feature. We send out weekly emails to our subscribers, email subscribers, tell them, hey, there's a Once Upon a Time in Hollywood going to be on. Will you be watching it? And a recent feature we launched is we not only sending the original weekly email, but we send our second email, basically shoulder tap that subscribers say, hey, if you come to see the Once Upon a Time in Hollywood, you get like 10% discounts. Will you come to see that? However, by sending our second email to our weekly newsletter subscribers, we observed our 20% lift in conversions. That's what we want. But we experienced a 20% increase of unsubscriptions. So basically, there are 20% of people, they received the second email, they clicked the unsubscribe immediately because they hate it. They feel like, why you are spamming me? I don't like DiCaprio. I don't like Brad Pitt. They are too old to me. So they don't like it. Why you send out those like irrelevant message to me? So that comes to the question from the marketing team to the data science team is, should we continue sending out this second email or not? And can we do our 1-year projection on the net impact? So how can we do that? Basically, the question, if I would rephrase, is to take the incremental of conversions and minus the projected loss from those 20% unsubscribers. And that's essentially the questions to the data science team. Then the data science team get this question, how can we solve this? And we're just data scientists. We don't know, well, we know something. And how can we solve that in an easier way? So I like to introduce the beta geometric and the Beta-Binomial model. So if you get out of this room, I hope you can remember this model. And I will make it simple for you to remember. First of all, this is called buy till you die model. And the second of all, it's very simple. It assumes each customer has two biased coins. So every person, when they interact with a business, they can have multiple reasons of not making a purchase. They have multiple reasons of not coming back to that store anymore. But if we think about it, we can collect all of the features, and we can run a neural net, we can run a deep learning model, and we capture all of the features and make predictions. Even it's overfitting, we don't care, but we just want all of the features. And we capture your demographic information, we know what car you will be driving, and all sorts of this. We make predictions. But think about that from a probabilistic perspective. As our sample size becomes bigger and bigger, your reasons is irrelevant to me as a business because all of your reasons are just the randomness to me. But what I really care is if I have a probabilistic distribution and I want to know where you are fitting, where you are standing in that probabilistic distribution. So how can we do that? We basically give like 2 coins to each of the customers. Flip it. Yeah, flip it. For example, first coin is a death coin. Okay. If it's head, you stay alive. You will still come to popcorn and soda and still watch movie from there. If it's tail, you die. No escape. The death floor is here. You decided, oh, popcorn, soda, they have not renovated anymore. I hate their seating, it's not comfortable. They have their air conditioning on and always cold. I'm not going back there anymore. So you get your tail from your death coin. And however, if you still decide coming back to popcorn and soda, basically you still get your head, then you flip the second coin you are given, which is the purchase coin. If it's good, we make a purchase. You make a purchase, and I'm going to see a movie. And if it's not, no purchase. I hate my coin. Why I was given this coin? So like I mentioned, one of the customer, from the 3 customers we showed, and it will be pick up and showing up here. So let's do a little bit like inside-out game using Brian as an example. We already saw that. Brian made a first purchase, come to see The Phantom of Menace. Then later on, he came back to see A Star is Born. So when there's a game, Avengers game coming, and he received that email, and what's in his mind? Supposedly, he just graduated from USC, and he recently moved to Hollywood, and he feel like, I do like the theater, but should I drive like 10 miles and make my way and just see a movie at popcorn and soda, and my friends are already gone, so how should I do that? Supposedly he did. He feel like, okay, I really miss the campus. I can even grab food from the old cafe, and I really liked it. So he flipped the first coin, the death coin, and he got head. So he's still coming back. He's still alive. He's not dead yet. And on the second coin, he flipped the purchase coin. He's thinking, okay, Endgame is on today, 8 p.m. and popcorn and soda. Should I go see it? So basically, he can stay alive, but now coming back, make a purchase. Also, he can be just dead, and he does not qualify to toss the second coin. How can we generalize this? Because we are not only care about Brian, we care Alice as well, we care Charlie as well. There maybe have a Daniel, Eric, and everyone else. We care all of those people from the business perspective. So a living customer dies at the beginning of a transaction opportunity with a probability of theta. This is known as geometric distribution. How many of them still remember geometric distribution? Very nice. Okay, for those who didn't raise your hand, and that's basically when any of you play Pokemon Go? Okay, so I'm surprisingly more people knows about geometric distribution versus like play Pokemon Go. Okay, so geometric distribution is you have those Pokeball and you just throw to a Pokemon. You probably were given like 5 Pokeballs, and as long as you hit a Pokemon, the process ends. So that's the geometric distribution. You have number of trials, you have 2 outcomes, success and a fail. And when the success reached, then the process stopped. That is a geometric distribution. And the second one is the purchase rate with the purchase coin, which is defined as with probability of P, and this is known as binomial distribution. So binomial distribution is very similar to geometric distribution. The only difference is you don't stop. So you keep doing that. Like your purchase coin, you keep toss it as long as your first coin is still or head. So here are the math equations. and Brian still showed up. So here comes the question. We know Brian made the first purchase on the first opportunity and third opportunity, but we don't know has he died yet at Kill Bill? Has he died at Shazam? We don't know when did he die. So there are different possibilities along his customer journey. How do we play this out? So in our statistical word, we call this likelihood. Okay. So let's say Brian's purchase history using our 1010 notation, then the probability of given his probability of the prior of P and theta, and we know his purchase is 100, stands for we have not observed he made a purchase. So in general, there are 3 scenarios. And the first scenario, let me just quickly walk through, is P, is he still alive? Because we noticed he made a first purchase. Second one, 1 minus P. Then the third one, 1 minus P. The fourth purchase opportunities, he made a purchase. And later on, and we don't know whether when he actually died. So we made our assumption that he died at the fourth transaction opportunity. So the probability, the outcome we predict is he has alive, then he dead. And given the fact that we are not sure when is the exactly timing he died, then we still continue this likelihood calculation for 2 alternative outcomes. Then we sum them up. So what we observed here is the order of the given number of transactions prior to the most recent transactions does not matter. So the order does not matter, but that really matters is the death, theta. The recency, basically, recency defined is when you define it as your loss of purchase till present and how many transactions you have made as frequency. And we compute the probabilities for on each of the individuals. And since they are independent, we multiply all of those probabilities, and we get the probabilities of other customers. When we are multiplying tons of probabilities, there are a lot of zeros, a lot of decimals. What are we going to do about it? So we're going to take a log about it. We're going to take a log. So we're going to cover that soon. I think the most sexy part about the probability model is it keeps the heterogeneity. So heterogeneity defined as distinctive non-uniformness, as everyone is different. Like I mentioned that because each people have different reasons about willingness to make a purchase, reasons of not going to see a movie, their demographics. So there are tons of reasons. And the beauty of a probabilistic model is it keeps the heterogeneity of the entire population. As we see from that graph, Alice, Brian, Charlie, they have their own set of coins. Since the model called BGBB model, and we have our mixture model, and we take the log of it for the computational purposes. And if those mathematical formulas you feel, I don't like it, they look disgusting, but I'm going to show you what is the data input. Okay, so the data input is actually very neat. It consists of just 4 columns: frequency, recency, purchase, and the number of customers. And what we get out of here is we got each customer, their predicted average order value, their predicted dirt, right? The entire presentation is about dirt. Then we have our predicted CLV at our individual level. That's where the heterogeneity comes from. So what I want to show here very briefly is each of the person have their own sets of coins. And how do we know the theta and the P for all of my customer base? If we basically can count like number different different coins you have, and we can have our beautiful histograms for our popcorn and soda. And however, and if we have as many people as possible, then the entire histogram becomes continuous. Then it gives us a beautiful beta distribution for theta and p. And I think most of the people don't like this chart, but let me explain this to you. So for any of the distributions, we can get the mean out of it. And why that mean matters to me. So the mean on the left-hand side, the theta, the mean, the expected value, which I calculated here, is 20%. As we can see that this is a 0.2. So that means my churn rate, my theta is 20%. So my churn rate is 20%. And on the right-hand side, that's my distribution of p. And the expected value is 60%. So that means giving you 10 transaction opportunities for my customer base, and you will make, on average, you'll make like 6 purchases. So that's for a lot of business or companies really like those indicators. And here comes a question. If we look at the churn rate, do you like this shape? Do you like this shape better? So raise a hand, like which one you like the red curve or like the blue curve? So how many people like the red curve? How many people like the blue curve? Okay, I'm sorry, those blue curve choosers, and that means like you have more people fell into the right-hand side, which you can see that your churn rate is actually higher. And here are our beautiful calculations of predicted number of transactions. And also here is a very interesting one, is about conditional expectations by frequency and by recency. So those basically answers the questions of how many purchases you will make in the future given your observed behaviors. So let me quickly go through how to select our right CLV model. First of all, we need to define business goals. And then we find out what is your business model, contractual, non-contractual, continuous, discrete, or you're just sort of in the middle. And the last 2 questions is how far out the CLV will be projected. And the last least is strategies and actionable insights driven by CLV. What are you going to do about it? Are you using that for our company valuation? Are you using that for marketing budget? So you need to define that. And you need to select your offline models. There are different tools. Python both of them have very nice packages. You can make a decision. Matrix-wise, use MAPE or any other source of the KPIs you want to track. And when deploy the online models, I think the key takeaway here is we would recommend to deploy that in a Docker container where we can have the full control of the packages and the versions. And also we can write the testing cases for the engineering code. So let's come back and just wrap up the popcorn and soda story we had. The estimated incremental revenue gained from the 80% conversion is about 3 million. And based on the 20% increase in number of unsubscribers, we projected CLV for a year is about 1 million. So the net impact from the calculation is about 2 million per year. From this note from the data science team to the marketing team and the executives basically tells them the net revenue impact is positive, so we believe that we can launch this product feature. What is the key message here? Everyone remembers the 2 coins example, the death coin, the purchase coin, and you can play around at home. So the key message here is there's no one-size-fits-all model when it comes to CLV. We demonstrated 3 models, and I think all of them are valid. Depends on how complicated you want to go. And on the second piece, our probabilistic models can be a really wonderful and an easy start. And the third piece is define your matrix. So as our industry standard, we usually use our CLV and CAC, which stands for cost to acquire a customer ratio. It's between 3:1 to 4:1. So you basically have a margin about like 25 to 33%. And last one, I guess this one is really just inspirational, is like the dreaming intersections of marketing and data science, as all of or some of us sitting here is to find the right people with the right product and on the right time. So, thank you very much. Yeah.
Questions? Please want to ask.
So how do you ever present any of those formulas to non-data or how do you, like, just your general strategy for, like, presenting this? Or do they share at all? You can just kind of do whatever, or even just helping the marketing team understand?
Right. So to be honest, if I look at my Google Drive, I have the same topic, have different decks, and each of them used for a different audience. One is for like marketing folks, and the other one for data science folks. And for this presentation, I did a blend with both marketing and data science, so try to keep everyone happy. And I guess my suggestion would be when we're talking to more like our marketing or business and even like executives, and we probably use a different or non-mathematical format, but walk them through the logic and why we do that. But in the final report or anything, like if they want some numbers, and let's make it more straightforward and but any like details, we do the reference and we give them the reference and where does that calculation come from, just in case some people are curious and they can look at them up. Yep.
Any other questions?
Just curious, for the predicting the future revenues then, do any of those metrics feed other departments in the company, like finance? They want to know how much revenues do I expect to make next month, and
Yes.
to what extent do they reconcile?
Yes. So in the appendix, I actually included like from like the second bullet point under or from our macro or more strategic point of view, like annual budgeting based on CLV. So that has been our we got a lot of requests from like finance or from the like the executives, like instead of we're using our forecasting model like our time series or like different breakouts by different business units, and they want to know the actual customer lifetime values for a year or for 2 years, for 5 years. Yeah. Also, the example I included in the presentation is one of the business case we have in the company. Yeah.
Actually, I'm very glad you put up this slide. Actually, that's the question I just want to ask. Your presentation focused on the macro side, right? How to look at the aggregate of customer and the model. And how do you get to the micro side in terms of identifying the most profitable customer and their traits and features, so you know how to target different market segments?
Right. So I guess I probably was not super clear about this, and on the output results. From the model perspective, we can have the predictions on their frequency and the recency buckets. So we will have our individual level of visibilities using these models. And also here in the model selection part, I haven't emphasized there are hierarchical Bayesian models like the Pareto GGG or Pareto MBD model. So it runs our Monte Carlo Markov chain process where you can have your parameters at each individual level. Yeah, hope that answered your question.
Can I follow up on that?
Yeah.
So once you identify those most profitable customers, do you have any work kind of understanding their traits and behaviors, and how do you do that?
Yes. So there are first of all, there are customer segmentations. So like I mentioned in this example of the red line or the blue line, so basically you can use that as a KPI to track the healthiness of your customers. You can segment that by running our simple our beta distribution for theta. And you can break it out by different business units, different products, different services. Then you can track the profit gained by each of the customer segments. And also, I'm in here, if we can, I mentioned in the third bullet point, it can dictate the allocation of the marketing resources, like each individual acquisition cost. For example, if we want to automate our SEM, like the bidding mechanism, then we can specify, hey, we are only spending this amount of dollars because we want to keep the revenue for some customer segments. Yeah.
The question is, do your models track the risk? Do you take into account, are there risk awards? Is there a risk factor that can be attributed to any of these models?
Can you elaborate a little bit about risk?
So the risk of stock market going down or something,
Oh, I see.
economic conditions.
Gotcha. Yeah, so that's a marketing 101 class we have. As a matter of fact, in the very slides here, D, if you see from the equation, 1 plus D is the discount rate, and it can be our indicator of the the depreciations, and also the currency inflations or a source of other risk factors. So for example, the 10% here, let's assume 10%, it is, and as a standard-wise, 5 to 10% is a median-sized companies use that discount rate. And if it's a bigger, large-sized companies, they probably use a higher, actually lower percentages of discount rates. So hope that answered your question.
Okay, guys, in the essence of time, we have one last question. And before that, I just want to make a quick announcement. There's a networking session that's right after this. And in front of the board are doing the same part where you guys had your lunch.
I know that there's one model that gamma that could be directly calculate the customer lifetime value.
Mm-hmm.
So I mean, have you ever tried to use that kind of model instead of a step-by-step calculation?
Well, so there are two pieces of it. I'm glad you asked. And the gamma model is actually addressing the predicted order value. So it's not addressing it addresses the monetary part. Right now, we're talking about the number of transactions.
Good. Thanks a lot, Fiona, for that excellent presentation.
Thank you.
From Beta-Con LA, this is Beta-Con Shortcuts.
Thank you.